The vast expanses of space have always attracted humanity with their mystery. Each of us has at least once in our life, looking at the starry sky, asked ourselves, are we really alone in this immense universe? This question haunts not only ordinary people, but also scientists, philosophers, and researchers throughout human history. As we venture further into space exploration and our understanding of the cosmos deepens, this fundamental question becomes increasingly complex and nuanced. In the 1960s, astronomer Frank Drake proposed his famous equation, which was meant to help estimate the number of civilizations in our galaxy capable of interstellar communication. This equation took into account multiple factors, from the rate of star formation to the probability of intelligent life emerging. According to the most optimistic estimates, thousands of advanced civilizations might exist in our galaxy. However, were they all? The Drake equation, while speculative in nature, provided the first systematic framework for discussing the probability of extraterrestrial intelligence, helping transform the search for alien life from pure speculation into a scientific endeavor. This contradiction is known as the Fermi paradox. Enrico Fermi once asked a simple question: where is everybody? If there are many civilizations in the universe, why haven't we discovered any traces of their existence yet? This question has generated numerous hypotheses and theories. Some scientists suggest that advanced civilizations might destroy themselves before achieving interstellar travel capabilities, while others propose that the vast distances between stars make meaningful contact practically impossible, even for highly advanced species. One of the most intriguing theories suggests that advanced civilizations might intentionally avoid contact with less developed forms of life. Similar to how anthropologists try not to interfere with isolated tribes on Earth, more advanced civilizations might adhere to a kind of cosmic quarantine, observing us from afar. This concept, sometimes called the zoo hypothesis, proposes that Earth might be deliberately preserved in its natural state for study or protection, much like a wildlife sanctuary. Modern science provides increasingly more evidence that the basic conditions for life to emerge in the universe are not so rare. The discovery of exoplanets in recent decades has shown that planetary systems are more of a rule than an exception. Many of these planets are located in the so-called habitable zone, where temperature conditions allow water to exist in liquid form. The Kepler Space Telescope alone has discovered thousands of exoplanets, with some estimates suggesting that there could be billions of Earth-like planets in our galaxy alone. Studies of Martian soil and the satellites of Jupiter and Saturn show that even within our solar system, conditions for primitive life forms might exist. For example, Jupiter's moon Europa hides an ocean of liquid water beneath its icy crust, where microorganisms could theoretically exist. Recent discoveries on Saturn's moon Enceladus have revealed organic molecules and complex chemical processes that could potentially support life. These findings suggest that even in our cosmic backyard, the conditions for life might be more common than previously thought. However, the existence of primitive life forms and the presence of advanced civilizations are different things. The evolutionary path from the first single-celled organisms to intelligent beings took billions of years on Earth. This process could have been interrupted many times by asteroid collisions, global cataclysms, climate changes. Perhaps the development of intelligent life is an extremely rare phenomenon in the universe. This concept, known as the rare Earth hypothesis, suggests that while simple life might be common, the conditions required for complex intelligent life are extraordinarily rare. Modern methods of searching for extraterrestrial civilizations have become increasingly sophisticated. Beyond just listening for radio signals, scientists now employ a variety of detection strategies. They look for technosignatures, signs of advanced technology that might include unusual infrared emissions from waste heat, megastructures around stars, like Dyson spheres, or artificial illumination patterns on exoplanets. Researchers also search for biosignatures, chemical signs of life in exoplanet atmospheres that might indicate the presence of industrial civilization. The SETI Search for Extraterrestrial Intelligence project has been systematically searching for signals from extraterrestrial civilizations for over 60 years. Although no significant successes have been achieved yet, new methods and technologies appear each year, expanding our capabilities in this search. The advent of machine learning and artificial intelligence has greatly enhanced our ability to process vast amounts of astronomical data, potentially increasing our chances of detecting subtle signs of extraterrestrial intelligence. Perhaps we simply haven't reached the level of technological development that would allow us to detect traces of other civilizations. As astrophysicist Arthur C. Clarke noted, any sufficiently advanced technology is indistinguishable from magic. Perhaps more advanced civilizations use communication methods and technologies that we simply cannot recognize or understand at our current level of development. They might communicate through quantum entanglement, manipulate dark matter, or use other technologies that are currently beyond our comprehension or detection capabilities. The question of the existence of extraterrestrial civilizations has not only scientific, but also profound philosophical implications. It makes us think about our place in the universe, about the responsibility for preserving and developing intelligent life that we know for certain exists. The pursuit of this question has led to significant advances in our understanding of life itself, consciousness, and the fundamental principles that govern our universe. Regardless of whether we are alone in the universe or not, the very fact that we are capable of asking such questions and seeking answers makes humanity a unique phenomenon worthy of study and preservation. Our ability to contemplate our own existence and search for others like us in the cosmos represents a remarkable achievement of consciousness and scientific progress. Ultimately, the search for extraterrestrial civilizations continues, and each new day brings new discoveries and technological possibilities. Perhaps the answer to the question, "Are we alone in the universe?" will be found in the coming decades. The James Webb Space Telescope and other advanced instruments are already providing unprecedented views of distant worlds, while new radio telescopes and detection methods are expanding our search capabilities. For now, this question remains one of humanity's most exciting mysteries, continuing to inspire scientists, philosophers, and dreamers to new searches and discoveries, while reminding us of our special place in the cosmic tapestry.